Hi everyone, in this video I'm going to talk about the Pythagorean identity. So it's called the Pythagorean identity because we can form a right angled triangle inside the unit circle like I have here, and we can see that sine theta is the vertical component, cos theta is the horizontal component. Now I'll just quickly fix up this example. Alright, so going back to this, Pythagoras' theorem tells us that c squared equals a squared plus b squared. So from this example, the hypotenuse is 1 squared equals a and b are just sine theta and cos theta, so I need to square them. And a nice way of writing this, well, 1 squared is just 1. Normally sine theta all squared is just written as sine squared theta, and likewise for cos becoming cos squared theta. Okay, now this here is the Pythagorean identity. It's a good one to remember, and you can see it's very similar to Pythagoras' theorem. So, given that sine theta is 5/13 and theta is between pi on 2 and pi, find cos theta and tan theta. To do this, first thing I need to do is write out the rule. So, 1 equals sine squared theta plus cos squared theta. In this case, sine theta is 5/12, so I have, it's 5/13. So I have 5/13 squared plus cos squared theta. If I square 5/13, I get 25 169ths plus cos squared theta. I can minus 25 169ths on both sides to be left with 144 169ths. And that's just equal to cos squared theta. So taking the square root of both sides, I get cos squared, sorry, that's not there anymore. So, sorry, I'm left with cos theta is the square or plus or minus square root of 144 over 169, which is plus or minus 12 over 13. Now, given that this is in the second quadrant, as theta is between pi on 2 and pi, I can rule out the positive answer. Okay, we know that cos in the second quadrant is negative, and I'll just say therefore cos theta is negative 12/13. The next part is to get tan theta. So to do this one, we need to know that tan theta is equal to sine theta over cos theta. So I know that sine theta in this case is 5/13 over cos theta, which is negative 12/13. The 13th part of this will essentially cancel out. You can go through using a state change flip or whatever way you have for solving this, but we just end up with negative 5/12. I probably should write tan theta there as well. So tan theta is negative 5/12. And that's done. I'm going to post another video which also goes over the same problem using a different approach and what I would consider to be a much nicer approach. So yeah, stick around for that one. Anyway, till next time.